All right, we'd like to welcome you to another in a series of webinars designed for departments of transportation. I'm Terry Bills, and I'm the Transportation Industry Manager here at Esri. And today I'm joined by a full crew, actually, from our partner, VHB. So we have Steve Anderson, Frank Gross, Dale Abbott, and Gary Stevens, all from VHB. And they will be addressing their work, the outstanding work that they've done with both Massachusetts and Connecticut DOTs on safety management. So this continues our trend of focusing on highway safety, as I think we all recognize that we could and should be doing a better job of preventing serious and fatal crashes in the U.S. It still remains the leading cause of unintentional deaths in the U.S. for every age from 3 to 23. And while nationally we've adopted fairly aggressive targets for reduction in car fatalities, in 2018 we basically only achieved a 1% decline in fatalities. So we really have to do better. So before we begin, I'd like to point out that we are recording this webinar, and while everyone will be on mute, there will be time for question and answers at the end of the presentation. So you can type your questions into the question box. We'll try to answer as many as time allows. And additionally, the slides which you see today as part of this webinar will be available to you on the GeoNet group, Departments of Transportation. And we'll give you that link and others at the end of the webinar. So to begin, there are really a number of slightly different approaches to highway safety, and we've highlighted several of these different methodologies in our past webinars. We at Esri have supported not only the IRAP and the US RAP protocols, which tend to focus on the design of our roadways and how we can design and retrofit our roadways to make them safer. And additionally, in the US, any number of cities have embarked on Vision Zero initiatives, which really came out of several approaches which were developed in Europe in the late 1990s. And today we're going to hear from VHB about their work with several DOTs in implementing the Highway Safety Manual, which represents another comprehensive approach to highway safety. And rather than me doing much else, let's have them describe their work and the outlines of their safety approach that they've taken with these DOTs. So I'm going to turn it over to Frank Gross to start off. And Frank, take it away.
All right, thanks, Terry. Let me see if I can share this. All right, well, as Terry said, we've been doing a good bit of work with some DOTs on helping them to enhance their safety management systems. So before the others kind of share those exercises and efforts, I want to talk a little bit about safety management in general and just what it means and the different components to it, because we'll be touching on several of those during the later demonstrations. So I'd like to give just a little bit of an overview of safety management, but also talk about the data that are required to manage a safety program. And that's where Steve and Dale are going to present on some of the crash data tools that we've been working with and some of the roadway data analysis that we've been conducting as well. So in general, the Federal Highway Administration and states have adopted this kind of goal of achieving a significant reduction in traffic fatalities and serious injuries on all public roads. And so that includes non-state owned roads and roads on tribal lands. And this is the Federal Highways HSIP, or Highway Safety Improvement Program, mission is really to achieve this significant reduction in fatalities and serious injuries. And this is done and going to be done through more informed decisions, better targeted investments, and that's really going to drive down the number of crashes and the resulting injuries and fatalities. So to make more informed decisions, we need the data to support that, and we also need the tools to help us turn that data into better information. So as a high-level overview of safety management, you can think of this as a three-step process, and that's planning, implementation, and evaluation. And Transportation agencies really need the tools to support this planning process so they can identify better projects, construct better projects, and then in the end, hopefully they're evaluating their efforts to figure out what's working best and what could be done a little better. Going into a little more detail on the safety management process, this is kind of how the Highway Safety Manual represents the safety management process, is through these 6 steps. And I'll go through each one in just a little bit of detail to give you some familiarity of what each of these is. I would like you to focus on the data requirements for each of these. So I'll spend a slide on each step just showing what type of data support each step of this process, because that's really critical to building tools and diagnosing issues. So the first step is network screening. And really what we're looking to do with network screening is take a look at the entire roadway network, whatever the agency is responsible for. So maybe it's an entire state or an entire city, and you're trying to pare down that network to a more manageable list of sites for further evaluation and diagnosis, because it's impossible to look at every location across your jurisdiction every single year. So for network screening, we may be looking at all of the roads, selecting some performance measure, ranking the sites based on that performance measure, and then really narrowing down the list of locations. So to do that, agencies have traditionally used crashes. So you might use crash frequency or crash rate and just looking for locations that have a lot of crashes. But there's more rigorous methods that are shown in the Highway Safety Manual, and those are shown toward the bottom of this table, like the empirical Bayes-based methods. Those incorporate the roadway data, traffic data, and other information such as safety performance functions to really hone in on those locations that have the highest potential or the greatest potential for safety improvement. So in this case, we need crash data, some basic roadway information, maybe the number of lanes, median type, things of that nature, and traffic volume for the entire network, and that would help us to conduct that network screening. Once we have that list of sites, we can then take a deeper dive into each location and try to investigate what's actually going on there, what's contributing to the crashes at hand, and what could contribute to future crashes. So we're really trying to get a handle on those underlying factors that either have led to crashes or could lead to crashes. So for diagnosis, we might be looking at things like the last 3 to 5 years of crash data, maybe mapping those crashes at the location to see if it's an intersection, which approach are they occurring on? Are they occurring mostly during the day or at night, during dry or wet conditions? So we're really getting into the details of the crash data there. We also, again, would look at traffic data, but now we might be looking at more detailed traffic data, like the turning movement counts at an intersection. We'd like to identify the detailed site conditions. Maybe now we're looking at the radius of the curve or the slope of the road. And then we would also typically conduct some field observations just to see how the road users are behaving. Once we understand the underlying issues, we can then come up with very targeted countermeasures to address those issues. So it can be easy to kind of jump ahead to countermeasure selection, but it is important to take a step back and really complete that thorough diagnosis. And that's going to help to identify what's the most appropriate course of action. And those actions could include the 4E approach, which it may be an engineering fix, or the contributing factors may point to more of a need for education or enforcement. For example, if it's maybe a speeding or red light running, kind of a behavioral type issue. So countermeasure selection will lead us to some potential countermeasures. So for that, we would need the results from diagnosis, this previous step. We'd also need maybe a potential list of countermeasures and a basic understanding of how much those countermeasures cost and how much benefit can we expect to get from them. So for example, you may have a table such as this that just says if you're looking at a right angle crash pattern and the underlying issue might be restricted sight distance, here's some general countermeasures you may want to consider to address that. Once you have a few potential countermeasures, you can start to compare those through this economic appraisal step. And this is the 4th step in the safety management process. So here you're actually comparing the relative costs and benefits through possibly a benefit cost analysis. And really what this is helping you to do is make the most of your money and identify those economically efficient alternatives. So the benefit should outweigh the cost, and then you're going to want to prioritize in general the higher benefit cost projects or countermeasures. So with this type of information, you can select the kind of countermeasure package or project that you'd like to implement, or possibly put forward to compete for funding against other projects within a program. So the data that you need for this, you would likely need the crash history to figure out if you didn't do anything, what would you expect in the future. The second thing there are crash modification factors, and those help to understand the magnitude of the benefit. So if you install rumble strips, maybe you would expect a 20% reduction in roadway departure crashes. Once you estimate the safety benefit in terms of the number of crashes, if you have these average costs of a crash, you can then convert the crash savings into a dollar benefit. And that's important because then you can conduct the benefit cost analysis and divide the benefits by these construction costs to come up with your benefit cost ratio. So that's the economic appraisal step. And that leads into project prioritization. So each individual site may have its own project that you come up with, but you can't possibly fund all of those projects. So now you need to compare projects against each other within a program and figure out where you're going to spend your safety money. So as part of project prioritization, you might consider other benefits as well. So you may be considering the safety impacts, maybe the operational impacts, environmental impacts, and then of course we always consider the construction maintenance costs as well. So for project prioritization, this gets into some non-monetary factors as well. So I mentioned the safety and operational impacts, but we might also consider here the favorability of the project. Is it supported by the public? We might also consider how ready the project is to go. So is the project far along with some plans, or is this going to take several years to advance through the project development process? And then once the projects are prioritized and funded and finally implemented, the last step of the safety management process is to evaluate the effectiveness of those projects. And this is a step that's too often forgot about because we identify locations, we come up with projects, we implement projects, and then we go back to identifying locations, coming up with projects and implementing projects, and we really don't take that step back and say, how effective were our projects? So this is something that can often get put on the back burner because you often have to wait 3, 4, 5 years after the project is complete to figure out how effective it was, at least in terms of the number of crashes that it may have affected. But that is critical to take that step back and look at because that's going to help us make better decisions in the future and change policies if needed. So if something is working really well, maybe that becomes a policy and a standard of every project that we do, we're going to include this safety measure on it. Or if something's not working so well, we can take a deeper dive and figure out, does it work better at some locations or others? Or maybe this is something that just isn't working in this particular location or jurisdiction, and let's think of other alternatives. So the data here, again, they should look very familiar by now, but we need the crash data, the traffic volume data, some basic information on the individual locations, like the project details, what type of countermeasure was it, when was it installed. So again, the more data that we have, the more reliable the methods that we can implement when we're evaluating the safety effectiveness of completed projects. So before I turn it over to Steve, I'll just leave you with this. I went through the safety management process quickly, but these are the top 10 from one of Federal Highway's resources where it identifies the top 10 characteristics of a successful safety management program. And VHB has been helping agencies to really achieve each of these 10 steps. So we've met with various agencies to either review or document their current processes and identify opportunities for improvement. We've helped with coordinating with internal and external partners and so on. What we're going to focus on through the demonstrations today is really 4 and 5 is really helping to utilize the data at hand and maybe even to collect some additional data so that agencies can make data-driven safety decisions, employ those advanced safety analysis methods that are documented in the Highway Safety Manual and other resources, really to make the most of their safety funds that are available. So with that, I'll turn it over to Steve and let him discuss how we've been supporting Massachusetts with their crash data.
All right, well, thank you, Frank. Yeah, as Frank said, what I'd like to talk to you about now is he mentioned quite a bit around how important it is to be able to collect and harvest the best sort of high quality crash data that feeds into many of these processes that were described. So what I'd like to talk about is how Massachusetts has been working to actually improve the overall quality of their geocoding system that they have through a new system we've been building for them called the impact system. And as 5 of the core components of that system, we built out sort of a platform for them that allows them to actually have access to better improved data and improve the way the data is actually created. So the main objectives of that project were really to look at, they've had an existing crash geocoding system that's been a desktop-based system that's been around for quite a while. So we're replacing that with now a web-based system. Another key characteristic to that system is they also have recently moved to roads and highways. So we want to be able to leverage the data in the roads and highways environment to pull that into the system itself. Third, there was a need that there are a lot of sort of small local law enforcement agencies around the state, particularly in Western Massachusetts, that don't necessarily have modern technology that they're using. So we want to be able to provide a mechanism for them to actually be able to have access and to provide better high quality data into the overall system itself. And we're doing that through a web services approach and an API. And what they're really looking to do is create a new system of record that could be used to make sure they sort of harvest and store the best data that's available, make that data available to the public, to researchers through a new crash data portal, as well as synchronizing that system with the RMV. So in Massachusetts, when you look at the way the system is actually put together, the RMV is the one that actually receives the crash data from the agencies itself, and then Mass DOT actually then works with that data. So we've had to put together a mechanism that would allow us to exchange the data with RMV and keep the two systems synchronized at the same time. But the other sort of unique characteristic of this is RMV is in the process of also building a new system itself, which made it particularly complicated for us to figure out how are we going to be able to support the legacy system they had, as well as make it easy to migrate over to the new system when that system gets created and put in place. So if I start out talking about some of these key components that exist in the system, the first key component is really the engine of the system, or the geocoding engine of the system itself. So the geocoding engine is a multi-tiered composite geocoding system. What it does is takes in the information that comes in on the crash reports. It determines whether or not geocoding can be conducted. It leverages all the different data sources that Massachusetts has available to them. So NAVTEX street and address data, the roads and highways data, landmark data, parcel data, and building points, to name a few of those data sets itself. The system itself is configurable, so each of those different reference data sets can be given different weightings and scores, so those can be adjusted through the life of those data sets itself, and then the scores are returned back to a user. So not only do they get the coordinates when a point's geocoded, but they get the status, the sources that was used, different scores and confidence that come in with those data sets, as well as other linked or derived data, like data that can be extracted from the roads and highways data set. The geocoding engine itself supports 8 different methods that can be used. So whether a crash comes in at an intersection or near an intersection, based on a street address, based on route and exit number or route and mile marker, through learn points, so points that aren't yet in the system itself can be added, such as new landmarks. When a new Walmart might be built and it's not yet in one of the systems itself, that could be added and sort of learned by the system. Also handles rotaries as well as simple field coordinates that can be put into the system. Now, the way the system works is it has a geocoding API that we built that is sort of the way that the system talks to the different components that are put together. So the geocoder is a web service that's put out that for real-time geocoding of crashes. It accepts all the different locational input parameters that can come into it. It calls the geocoding engine and then it returns those results back to the caller. It could work in two different modes, so it could actually provide just locational data back to the smaller agencies like the LEAs, or it can also take this and create a record in the system for geocoding for subsequent processing when the score in particular is lower than what MassDOT would like to see. So what happens is as the record comes in through the geocoder, it adds a point feature and a record for the crash into it automatically with it if it comes through as a high confidence level. But if the confidence level is lower, then it passes it off and adds a record into the inbox for low confidence to be used in what's called our interactive crash locator, or the ICL, that I'll talk about in a second. It also tracks and records the geocoding results for performance monitoring. There's a number of dashboards that have been put together that MassDOT could actually look at. Now, as I mentioned, one of the key pieces for those smaller agencies is the LEA web form. So the LEA web form is a form that is provided through a number of different interfaces. So they could use a mobile device or a tablet or a desktop-based PC. Come in, put in the characteristics they know about it, whether a crash is at an intersection, not at an intersection, and get the results of the coordinate that gets passed back to the system. One of the other key characteristics we have to be able to handle is doing reverse geocoding as well. Some of the law enforcement agencies will carry a GPS, but they want to be able to get all the other characteristics from the system so they can pass in coordinates and then be returned the other data that they're looking for. And then the final way, the third way, is also to provide them with a simple map-based assistance. So in this case, they have an Esri base map. They could go in, they could look at the crash. They might be at a different location, drop a point on the map, and then it'll actually return those results for the coordinate sort or the other input they're looking to get coming back. Now, as I mentioned earlier, one of the key characteristics of the system was the fact that the RMV system was going to be changing in the future. So one of the things we had to do is plan for a mechanism to change the data. So we've done that by accomplishing and building what we call the crash data bridge. And the crash data bridge is actually the component of the system that keeps the two systems synchronized. So it allows the RMV database to pass the crashes that have come in from the previous night through it, creates the records in the system itself. It identifies which ones can be automatically geocoded and passed through, or which ones will need to go to the ICL. What it also does is it then also does a round trip, so that if crash data has been updated on MassDOT's side, that crash data and the improved coordinate data can be passed back to the RMV system. So things like the crash location, the status of the crash metadata, as well as other characteristics like the roads and highways data can be passed back. The other thing it does is it handles crashes with a location or without a location, so because some of the agencies just don't pass enough information, so we have to track crashes that can't be located at a particular time. Well, the next piece of the system is the component that handles the crashes that do have a low confidence level. So this is the interactive crash locator. So it's an interactive operated assist tool that allows them to process the sort of the rejects that come into this queue. It allows them to view all the information. So as Frank was describing, sometimes you need to see more characteristics. So you might want to have access to diagrams or narratives that are there, be able to review those, review the data that's come in, decide which point that you want to use. And the system actually allows the user to come in and see everything. If they're an administrator of the system, they could see all the crashes that are in the inbox. They could assign those to different individuals. For the ones that are lower level folks using the system, they'll see only their crashes that have been assigned to them, but then they have access to all the other data, locational data, location history, the candidates that are developed, as well as the narratives and the diagrams and other scanned documents that could be updated into the system. Now, after the crash data itself is getting improved, another important characteristic of this was giving access to the data to both the internal users and the external users of the system itself. So for that, we've created a crash data portal, which is the single point of entry for external and internal users to get in. It provides guided workflows for them to find what they're looking for, whether it's a dashboard or a particular report that they want to run, and also tracks the aspects of what's being used by the system and that, so that we could actually look at what could be improved in the future. So when you first land on the crash data portal, what you see is an interface that gives you sort of a dashboard that you could pick from which component of the system, as well as on the right side of the screen here, different characteristics that are presented out to sort of pique interest of the users so they could see highlights of what's going on in the state. As they then start drilling into one of the components, like in this case, I'm drilling into the dashboard components. The dashboards themselves are organized into a number of different categories. And as I continue drilling into those categories, I could then get to a particular dashboard that I was looking for. In this case, this is a fatal information year-to-date dashboard, and this is leveraging Esri's open operations dashboard to actually do this. And you can see that you have the ability within this dashboard to then further filter down the data by year, by geographic region, by the characteristics of a crash itself, or a type, and then see the subsets. The dashboards are all fully interactive, so as I select on one of the components itself, it updates and provides me more detailed information about the particular characteristics that I've selected on, as well as I could then also look at some of the other dashboards that allow me to look across multiple years worth of data. So in this case, looking at the severity of crashes across a whole number of years that of a swath of time that I actually want to see the data and what's going on across those time periods. Now, for the components of the system that were more dynamic and where Massa actually wanted to be able to query and visualize the results better, we built another tool that's called the Query and Visualization tool. This tool allows you to drill into the data, whether it's crash data, vehicle data, or person level data, look at it by time, and the queries are much more parameterized and can be more dynamic with what a user is looking to get at. So as they go into the system, the first thing the system does is it does respect the credentials of the users. So we have a guest user as well as fully credentialed users that could get to all levels of detail of the data itself from Massa employees themselves. As they come in, there's a basic search of the system itself that allows me to select from the different attributes that are available to me, select the ones I want or groups of attributes that I want to find. If you'll notice on the right side of this screen, it shows the query speed estimator. There are somewhere over 150 attributes that we're actually storing in the system across all the crashes. So to be able to query across a large number of years and a large number of attributes, we have to build a component in that estimates how long the query will actually take based on the volume of the data that you're selecting. As I continue down, I have the ability to do either basic, advanced, or spatial searches. So the basic search allows you to sort of search on more of the common characteristics that somebody's looking for. So a time range or a time of day, either date or time, particular city, town, RPA, region, or district that somebody, as well as typical crash and vehicle characteristics. The advanced search gives you full capabilities to search across all of the data that's there and available to you. And then the spatial search is a piece that allows you to actually come in and leverage the Esri technology that's in there to do things like select a particular roadway area itself, buffer that by 600 feet, and then select it and query the data that's within the buffer that you're looking for. Then finally, the V part of the visualization allows you then to get an interactive set of data you can work with. So you can interact with both the map and see those characteristics of the mapping interface, as well as charting the data that you've queried on and selected, as well as look at the individual records. And if you notice on the right here, you can see that all of the items that are in the tables that are shown here are also filterable. So you could further detail down whether you want a particular crash date on this subset of data, or the time, or other particular attributes that you've selected. So it gives you the ability to continue actually drilling into the data. Then the last piece is the reporting component of the system itself. So there are quite a few standard reports that That was looking to have, the old system did all of its reporting based on Microsoft Excel, so we've deployed now SQL Server reporting services to replace this. Using this technology, we've been able to drastically expand what the capabilities are. Similar to the dashboards, you could see the reports gallery that you could start drilling into to find a particular category of report you're looking for. And then as you actually go into the system further, you get a preview of the data that you're looking to report, view on, still have filtering capabilities within the report to further refine it. And then you have the ability from there to actually export that report out after you've done a further geographic search on this, such as selecting all the crashes that are in Agawam within a particular time range. And then finally, we wanted to be able to provide the capability still to export the data. So if there are further searches or capabilities you want to have that you can't perform within the system, you have the ability to download the data and then work with the data outside of the system in Excel or other statistical tools you might want to use. Now what I'd like to do is turn things over to Dale Abbott, who's going to talk about what we've been working on with Connecticut DOT.
Thank you, Steve. So I'm going to go ahead and give you an introduction to our Connecticut DOT safety management system that we've been working on in conjunction with the Connecticut Transportation Safety Research Center, or UConn. So Steve just presented to you the crash data side of things, and our project focuses on, so once you have your crash data in your system and you've vetted that data, now you're ready to go through and go through the advanced safety side of things that Frank touched upon earlier in his presentation. So just a couple of quick overview slides here, and then we'll jump into a demo. So funding for this project was paid for by HSIP funds, and the goal of the project was to turn the 6-step roadway safety management process into a customized safety management solution for the DOT. It's really an implementation of the highway safety model manual. And what's a little unique about this project is that VHB staff worked together with UConn staff to build out this custom solution. And we took what we call an agile development methodology, where we went ahead and captured all the requirements, but the implementation of the system itself has been rolled out incrementally. So we started with network screening, then we moved on to the data admin module, to diagnosis, to countermeasure selection, and we're currently working to build out the complete system by the end of this year. So again, it's a custom GIS web-based application. It's a single-page application that leverages the Esri software stack, particularly ArcGIS Enterprise. We're using the ArcGIS JavaScript API 4.x. The system has a SQL Server backend. We have a middle tier of .NET Core web services, and the system itself is built out within an Angular framework. So just a couple of quick introductory slides. And what I'm going to do is switch over to the application itself. So again, it's a web application. So we have a login. Once you log into the system, you're presented with a dashboard that's basically providing you with some information in terms of application updates, new releases, bug fixes, and so forth. So over here on the left-hand side, we do have a data management module, which I'll talk about towards the end. But really going to focus on the safety analysis system here. So you see the 6-step processes that Frank described earlier. We're going to start off with the network screening engine. And each of, as you see, it's a single-page application. We're not switching pages. So each one of these tools has a grid for each one of them. So you can see what you're looking at is a grid of network screening scenarios that I've previously run. But just to show you how it works, we can go ahead and create a new scenario. So Esri webinar test demo. So this is very much like a wizard, where the first step is to establish your focus. So we have a connection to Connecticut's crash data repository, and in fact, we have a copy of that data within our application database. And the first thing that you want to do is select your crash range. So we're looking at 2016 to 2018 crashes. We did add in this emphasis area. So if you wanted to look at particular emphasis areas such as, impaired driving, young driver involved crashes, you can go ahead and select these particular emphasis areas. And then the other thing you can do is you can look at different crash severities. So if I wanted to just look at my Ks and As, which are fatalities and serious injury crashes, I can go ahead and make that selection, or I could run it against all crash severity types. And similarly on crash types, I can look at multi-vehicle crashes, and that's broken down by crash type or single vehicle. So I'm going to go ahead and just select all crashes. I'm going to hit continue. The next step is to identify your area of interest. So we could run it on the entire state. Some of our end users will be regional governments, council of governments. So we've built in some tools in here that allows you to select different areas of interest, which is boundaries. So if I wanted to select council of governments, I'm then presented with a list of COGs. So if I select this one, and again, this is all based on the Esri framework. So I can hit continue. And the second component of identifying your network is we break down all of the different roadways within that council of government. So if I wanted to just look at a particular route, I can do that. I'm going to go ahead and just leave it as it is and run it against all 27 routes within that county of government. And then we have some additional filters, so we can look at different facility types. So if we want to run our network screening against ramps, we break that down by entrance ramps, exit ramps, and other ramps. If we wanted to look at segments, we break it down by state segments or local segments. And again, we split it down into these different facility types: urban versus rural, undivided versus divided. And then we also do have some intersections in here. And again, the site list that you see here, these site counts, 367, 1102, these are a count of the sites within that area of interest that I selected previously. So I'm going to go ahead and say all facility types, hit continue. Then I get into selecting my performance measures. So and all along the way, we have help sections here to help the user out in making selections. We have a user manual that can be pulled up at any time. But this is basically getting into the different safety performance measures in regards to how we screen the network. And each one of these, so average crash frequency, relative severity index, they all have different equations behind them and have their own methodologies for ranking different sites. So for now, I'm gonna, the default is to run it against all performance measures. We have different ranking screening methods. So we have simple ranking. If I come back here and just select route segments, you'll see that this list changes because sliding window, which is another screening method, so I can select, basically as I traverse a roadway network, I can analyze that network in what we call just a simple ranking or a sliding window, where we slide a window along that route and we summarize and analyze that segment. So rather than looking at the complete segment, we break it down into individual pieces. So if I wanted to increase this to 3/10 of a mile windows and I increment it every 1/10 of a mile, and again, this is configurable, you can update it. And then at the end of our network screening, before the user goes ahead and runs the network screening, we present to them a summary of the network screening. So a review of the crash data, the network that's being used, the different performance measures, and our screening methods. And at this point here, the user could go back, they could edit this scenario, or click the button to run the scenario. And depending on the number of facility types and the screening methods, this may take a little bit of time to run. So at this point here, you would go ahead and run the scenario. You get a message saying that it's been submitted to our network screening engine. You'll receive an email notification when it's complete. What I'm going to do is go back into our grid view, so I can go ahead and I've run some of these previously. So if I want to go back and look at my results of network screening, I have a map view and I have a grid view of the results. So I can click on my results up here in the grid, and the map will zoom to those locations. You're presented with the different facility types that you've included in your analysis. You get some basic attribute information about the segment. And then this is where you get into the different performance measures that we looked at to screen the network. And the reason why we want to run multiple methods is that, like I said, each one of these has pros and cons to it. So you're able to go ahead and re-rank these sites looking at different performance measures to come up with the highest ranked sites. So again, interactive map, some basic attribute information in a pop-up window that's presented to the end user. And so, as Frank noted earlier, when you're done with network screening, so once you've identified your sites, you move on to the diagnosis module. And again, you have that grid view. I'm going to go ahead and open up a diagnosis module that I've already started. And the idea behind the diagnosis module is that there's kind of a suite of tools in here that the user is going to look at in making in determining those contributing factors associated with the crash. And so we start off with a map view. The crashes are color coded by the severity. Okay, so just a simple view of your site and the relevant crash data. And then we can step into these different tabs and start pulling in the individual crash data. So with the crash data, we're looking at the vehicle crash information. We're looking at the persons involved in the crash. Like I said, the types of vehicles. So all of the attribute information associated with the crash database, we've brought into the system. It can be filtered down, can be exported out as a CSV file. The next tab that we have here is our summary statistics tab, which takes just a minute to load. So we go through the crash data and we pull out some of the emphasis areas, just a quick little dashboard view of the crash information. And then we have some predefined reports, and these are built off of SQL Server reporting services. And you can go in here and pull up a number of predefined reports. We worked with the DOT to come up with this list. So looking at severity, crash type, weather conditions, and so forth. And we also provide the user with the ability to create their own reports. So these are the pre-canned ones that we have. They can go in here and create their own reports. Some of the other tools that we have, test of proportions, which takes a little bit of time to load here, but basically it's a statistical test that helps identify if within your site that you've identified, if there's any overrepresentation of crashes compared to similar sites across the state. One of the other tools that we have here is a collision diagram tool. So I'll go ahead and open this up. And this is a really a neat little tool where when you first load this, your crash data is clustered. And as you zoom in, you start to see the individual crash locations. And what this tool does is it allows you to build a collision diagram. So it's interactive. I can select a crash, I can move it. So we have an instruction menu over here on the right-hand side. And then we have some tools in here to view the crash details. So I can go up and pull up a narrative. I can open up the officer's diagram of this crash. I can change the collision type if, based on a review of those details, I find that there was an error in the way that this was coded. I could come in here and change the, like I said, the collision type. The other thing that we have here is we have a label that represents the total number of crashes on top with the injuries on the bottom. So I can go ahead and I can recolor code the diagram. Some other things that we can do is we can rotate the crash. And again, the idea behind the application is to be able to create a graphical representation of the crashes at this location. So there's a number of tools in here, more than I'm probably able to demo to you in this short amount of time. But at the end of the day, we're able to preview and save that collision diagram. Give it just a second here. So again, we have a map server set up here with some printing services to set this up. But so you have your legend, you have a view of your crash data, and you can save it. This information is then saved with the your collision diagram, or excuse me, your diagnosis module. Some of the other tools that we have in here are building a crash tree. So this is just another graphical way to view the crash data taking place at your site. So I can go ahead and choose these different parameters. And as you see here, it just builds a tree of information. I should have selected some of the additional attributes. So basically you can break those 13 crashes down into what we call a crash tree that summarizes the data by basically whatever characteristics you have in your crash database can be brought in here and build a graphical representation of that. Supporting documentation, so you can upload relevant studies, corridor studies. If you've gone out and done a site visit, you can pull that information in here and document your diagnosis. We also built in this site conditions tool, which allows you, if you can't go out into the field, it allows you to pull up either a Bing or a mapillary view, so a street view image of your location. So you see here highlighted in blue, this is my my segment that came out through network screening, and the purple dots here are the surrounding crash data. And as I interact with the map on the right-hand side, it's updating here on the left-hand panel as well. And Connecticut DOT leverages the mapillary product, and so they've been driving their roads and uploading that imagery into the system here. So that was one of the requirements, so that, you know, rather than going out into the field, leverage mapillary to get that street view component of your site. And again, you can save that information. And then at the very end, each one of these tabs has the ability to save and include it in a final report. So again, the goal of diagnosis is to come up with a list of contributing factors associated with your site. So that is a very quick overview of diagnosis. And finally, I just want to quickly show our countermeasure selection module. We just recently released this earlier this month, and we're currently working on these economic evaluation. We just went through the requirements on this the other day. But so for countermeasures, this is going out. We have an integration with the CMF clearinghouse as part of this project. We worked with them. They recently were setting up an API so we could read in their crash modification factors and get a live feed. And so what this is, it's pulling in all the CMFs. I can do a keyword search. So if I just wanted to pull in speed, I could look at all the CMFs associated with speed. I can go ahead and click on them and link out to the crash modification factors clearinghouse and get some additional information. And again, what we're doing here is once we've identified the contributing factors, well, what are the countermeasures to those contributing factors? And so you could go through here and you would select your countermeasures to address the contributing factors. One of the things that we have here is we have we can link back to our diagnosis. We can pull in our roadway characteristics associated with this site. And then again, we're able to summarize our countermeasure selection and any notes that we may have. So I apologize that was a very quick demo. This usually takes about 45 minutes to get through. So just a quick overview for you. And I think with that, we'll open it up to questions.
Okay, thanks, Dave. And anyone who wants to ask a question, type it into the question box, and we'll get to as many as we can. So let's see. It says on the Connecticut. So this would be for you, Dale. Can you use the module to select a single route instead of? Let's see here. Let me pop this out. Instead of a network, and can the generated network be ranked by route by crash data generated? And they're saying that would actually be used for project ranking.
Yeah, so we the tools that we have right now, you can specify a road network. Like I said, you have that process of windowing down the area of interest that you're looking for. So you could do a corridor analysis. So if you drilled into an MPO, for example, and you only wanted to look at one route within that MPO, you could do that and run the network screening against that one particular route.
Okay. And does your network screening include all local roads?
Not currently, but we are working on that. The intersections is something that's still being developed as well, but as that information is available, it's getting loaded into the system.
Okay. And let me go back to you, Steve, and while you presented the really sort of the geocoding engine and so forth, can you my experience is that really the importance of getting the crash location correct is critically important, and so really the ability to do the proper geocoding. Can you speak a little bit to that?
Sure. Yeah, I think the process that's been built in where we have all of the different methods that are supported, and the way the user can actually adjust the parameters that are taken into account to provide a confidence level across all the data sets was really a key characteristic of building the system itself. It allows the data to improve over time and the quality of the crashes themselves to also improve over time. So, leveraging is Massachusetts has a lot of different data sets that are available. So we've been able to leverage a lot of those holdings that they have at the same time actually ranking them. So the ones that they feel more comfortable are the higher quality data sets can be ranked appropriately and used for improving the quality of the crash data.
Right, and we don't often point out often enough that really all the downstream analysis is really dependent on getting those initial crash locations accurate. So, okay, back to you, Dale. There's a question. The update SPF feature on the left side, there's a question as to what that was.
Yes, so we did, the data management module is something that was developed after we built our first module, network screening. So what that does, it allows us to go ahead and re-import our roadway network to prepare our homogeneous segments for SPFs, and it allows us to update our network screening SPF. So it allows the safety engineer to go in here and update any of the parameters that may need to be updated on an annual basis. So that's something, rather than developing some scripts that run outside of the application, we're trying to do as much as we can within the application to automate the update of the data sources.
Okay, and this is a question probably for you, Frank. It's in what ways has the VHB developed safety management system an improvement on the AASHTO safety analyst software? And can you speak to the meaningful differences in the data management steps and in the requirements?
Yeah, and I think if Steve and Dale want to chime in on this one, they can certainly feel free to do so as well. This is more of a custom solution, so it's application-based solution for individual agencies. So it's building with the data they have and really structuring it in a way that's going to support their decision making. I think the AASHTO Safety Analyst software really provides a nice platform for others who are looking for more of a canned solution. In terms of the the data, I think these types of safety management systems offer a little bit more of a spatially enabled analysis functionality. So in terms of the data integration and data management, Steve, did you have anything to add to that, or Dale?
Yeah, I think Dale might be good to talk a little bit about when we started the Connecticut project. We did an evaluation of all the different products, including safety analysts that were out there.
Yeah, that's true, Steve. So before we started this whole process, we did do that evaluation of existing products, and the DOT just felt like what was out there on the market didn't work for them. They wanted a web-based solution, so they didn't want something that had to be deployed to end users' local machines and managed by IT. This is just a web login. And the other thing is the GIS integration in the visualization side of things. That's probably one of the biggest areas where the systems that we've built with UConn here exceeds safety analysts, for example, just the direct GIS integration and the mapping components where it's all within one application.
And this is Terry. Just the number of variables that you have in the Connecticut system versus safety analyst, I think, is 120 some attributes that it really depends on. How many did you have for Connecticut?
In terms of the roadway characteristics?
Yeah, roadway and crash type and so forth. The total number of variables.
Off the top of my head, I'd have to say it's close to 100 in terms of just all of the crash data that's available within the state's crash data repository. That information is available, and we have pulled across at least a couple dozen roadway attributes that are maintained by the DOT.
Okay, and there's a question about how many users outside of the safety group within Connecticut, how many use this application?
So right now, this is being expanded. So the DOT is using it, but there's a number of MPOs that have asked for access. So that's one of the things that we're currently just about ready to implement, is allowing users outside of the DOT to access the application. The intent is to have about 35 users within the DOT.
Okay, and the same applies to MassDOT as well, the Massachusetts solution, correct, Steve?
Yeah, it is. It's initially designed for sort of the core internal users at MassDOT itself, but a lot of what they want to be able to do is with some of the aspects of it, like Q&B and the data portal, actually giving people access to the data outside of the organization, so that they could take the workload off themselves and have it be more of a self-service application that people could come in and get the data and the answers they're looking for.
Okay, and sort of a final question, how many total crash records in the database for Connecticut and then for Massachusetts? Rough numbers.
Massachusetts is around 6.5 million, I believe.
And in Connecticut, I'm honestly, off the top of my head, I'm not sure. There's got to be a couple million records in there, though.
Yeah, so, okay, and so, all right, well, with that, we're going to have to close it off, and we want to thank thank everyone for attending today. Here's a slide with some additional resources, and we'll also include the links to the federal highways that Frank referenced. And with that, we'd like to close it off, and thank you all for joining today. So again, thanks, and thanks to everyone at Frank, Steve, and Dale at VHB. A great webinar. Thanks again.